Welcome to the first video of Module 2 on IPv4 address exhaustion, coexistence, and transition. We'll discuss the following ideas. What is an IP address? IP address assignment hierarchy. History of IPv4 address exhaustion. IPv4 address exhaustion forecast. What is an IP address? An IP address is an identifier used by the Internet Protocol in Layer 3 of the protocol stack, which is known as the network layer. An IP address allows identifying the network interface of a device connected to the Internet. In the image, each device with a network interface has a unique IP address that identifies the device and allows it to send packets from IP1 to IP2 and from IP2 to IP3. IP addresses are also used by routing protocols to calculate the best possible path to reach a given destination IP. The uniqueness of IP addresses is an important concept. For the packet forwarding system to work, the same IP address cannot be used for several sites. Instead, each IP address must be assigned in a well-defined, systematic way and configured on a single device interface. As the figure shows, if a device with an origin IP wishes to send a packet to a destination IP, it will create its IP packet with certain specific data. The packet will jump from one routing device to another. If the destination address is shared by several locations, it would be impossible to know where to send the packet. This is why it is important for IP addresses to be unique. It is the only way to know how to send the packet to its destination. Similarly, if the origin IP is unique, a response can be returned. In short, remember that any device that intends to communicate, whether sending or receiving packets over the Internet, must have a unique IP address. Given the growth in the number of users and devices connected to the Internet and in using an IP address, the number of addresses available in IPv4, the first version of the IP protocol, is clearly insufficient, as we will see in this video. IPv4 addresses. The number of bits used to code IP addresses is determined by the IP header. In the case of IPv4, the header uses 32 bits for the address fields, thus creating a space of 2 to the power of 32 unique addresses, almost 4.3 billion addresses. This address space is divided into 256 parts, each coded using 8 bits. Each of these parts is known as a /8, a reference to its prefix notation. Each /8 contains a little over 16,777,000 unique addresses. Out of the 256 /8s, the equivalent of a little more than 35 blocks are reserved for specific uses, such as multicast, future use, local identifiers, loopback interfaces, and private use. The remaining 220,992 /8 prefixes are available for use on the public IPv4 Internet. Now, let's see how these addresses are assigned. IP address assignment hierarchy. Internet number resources, that is, IPv4 and IPv6 addresses, and autonomous system numbers are managed and assigned hierarchically. The organization at the highest level of the hierarchy is the IANA, a division of ICANN. Among other duties, the IANA is the organization responsible for assigning Internet number resources to the RIRs, IP addresses, and autonomous system numbers. The IANA assigns IPv4, IPv6 addresses and autonomous system numbers to the RIRs according to their demonstrated needs, following a set of global policies. RIRs operate as non-profit, membership-based organizations. There are 5 RIRs worldwide, each serving a different geographic region. LACNIC was created in 2002 and serves the region of Latin America and the Caribbean. Each RIR manages the address space received from the IANA according to its own policies, which are proposed, debated, and finally agreed internally by the RIR community. In certain cases, RIRs will sometimes assign space to a National Internet Registry or NIR. There are, however, few such cases worldwide and only 2 in the LACNIC region, Mexico and Brazil. In turn, RIRs or NIRs in the countries that have them assign addresses to their members. Local Internet Registries, LIRs, also known as ISPs. ISPs will then assign IP address space to their customers, the end users. In certain specific cases, an RIR or NIR may assign addresses directly to end users. The image shows the relationships between different Internet agents, as explained earlier. History of IPv4 address exhaustion. In recent years, we have witnessed the gradual exhaustion of IPv4 addresses at various levels of the hierarchy. First, the IANA's address pool was exhausted on February 3, 2011, when the organization allocated its last 5/8s, one to each RIR, an event marked by a solemn ceremony that was streamed live. Next, it was the turn of the RIRs. APNIC's IPv4 address pool reached its final /8 on 15th of April 2011. RIPE NCC's IPv4 address pool reached its final /8 on 14th September 2012. On 23rd April 2014, ARIN announced that its IPv4 address pool was down to 1/8 and that this had triggered the final phase, Phase 4, of its IPv4 countdown plan. On 10th June 2014, LACNIC announced that, as agreed by the regional community, now that only 4,194,302 available IPv4 addresses remain, just 1/10, LACNIC's pool of IPv4 addresses is considered officially exhausted, and the gradual exhaustion and new entrance policies have come into effect. This means that, currently, only AFRINIC continues to operate under its regular IPv4 address assignment policies. IPv4 address exhaustion forecasts. IPv4 address exhaustion projections have been around for some time. The Putaru website provides some interesting information. It shows the projected exhaustion date for AFRINIC's address pool, the last remaining RIR operating under pre-exhaustion policies. The big question that is still to be answered is when ISPs will run out of IP addresses and what solutions they are planning to implement. Each case will be different, and only time will tell how this issue will be finally resolved. Thank you for your attention. You have watched the video on IPv4 exhaustion projections. In the next video, we will talk about available IPv4 space.